All right, pre-calculus 10.3 day 2, more on ellipses, and we have just a quick little warm-up here. And so the center is going to be at negative 3, 2. And a squared is always the larger underneath the denominator when it's in standard form, so a is going to be 4. And since it's underneath y, you're going to go up 4 and you are going to go down 4 to get your vertices. So you're going to add 4 to the 2, and you are going to subtract 4 from the 2 to get those vertices. B squared is 12. So b is the square root of 12, which is 2 root 3. And that's a little bit over 3. It's somewhere between 3 and 4. So you have a covertice somewhere here and another covertice somewhere over here. And then c squared is your b squared minus your a squared. So it's always that larger in the denominator minus the smaller when it's in standard form. And so you get c is 2 because that's 4 and the square root of that is 2. So you need to go up 2 and down 2 to get your foci. And your foci from the center are going to be at negative 3, 4 and at negative 3, 0. And then try to sketch this in here. So you have center vertices, foci. The covertices are going to be from the center plus or minus 2 root 3. And then up at 2. And your eccentricity is your c over your a. And eccentricity, you need to simplify that, is 1/2. So just a little bit on ellipses. And now you are going to be given some different pieces rather than just the equation. And from the pieces that you get, you need to know how to find A, B, and C and figure out, is it longer horizontally or vertically. And so find the standard equation of ellipse having vertices at 3, 0 and negative 3, 0. And when I see that, I know that the distance between the vertices is going to be 2a. And the distance between those are 3, so the value of a is 3. Also, the midpoint between the vertices which is just 0, 0 is going to be my center. So this is centered at the origin. And the distance between foci is 2c. And so c is going to be 2. So here's a focus and here's a focus. And the distance between the foci is 2. And then to get the covertices, I get c squared by taking a squared minus b squared. And I know c squared is going to be 4 because I know c is 2. And a squared is going to be 9 because a is 3. So I can get b squared by taking 9 minus 4. And b is the square root of 5. And so my covertices are going to be up and down from the center, the square root of 5, which is just slightly over 2. So here's a covertice, and here's a covertice. Now we need to go ahead and find the equation. we always put x squared first and we put y squared second, and since it's centered at the origin, we don't have the quantity x minus anything or y minus anything. And a squared, since it's going longer left to right, the a squared goes under x squared. And the b squared goes under y, and that has to equal 1. So you need to know that the distance between the vertices is 2a, the distance between the foci is 2c, and the distance between the covertices is 2b. The distance between the covertices is 2b. You need to know that as well. All right, standard equation of the ellipse having foci at negative 2, 2 and 4, 2. And so the distance between the two foci is 2c, and the distance between those is 6. And so the value of c is 3. And also the center is going to be the midpoint between the two foci. So you add up the x's and divide by 2, and you add up the y's and divide by 2. So my center is at 1, 2. And since it's an ellipse, I already know for the standard form I'm going to have x minus 1 squared plus y minus 2 squared over values and equal to 1. The foci are always on the major axis, so I'm going to have my a squared, my larger squared value, is going to be underneath x. And the length of the major axis is 2a, because it's the distance between vertices. So that means a is 5, and that means under x minus 1 squared, I have 25. So there's my center, so that would put a vertice here and a vertice over here. Now, c squared is a squared minus b squared. And so c is 3, so squared is 9. A squared is 25. And b squared then is 25 minus 9. And b squared is 16. And that's what I need. I actually don't need b. And there's my equation. So it didn't require that you graph it. I mean, we could. But it's just there that sometimes it kind of helps you with what is a squared, what is b squared, where to put it, and there you have it. All right, and then standard equation of ellipse with vertices 0 plus or minus 8. So we're up here. We're down here for the vertices, and that means that the center is at 0, 0, because the midpoint of those vertices is 0, 0. So when I'm doing my standard equation, I have x squared over something plus y squared over something equals 1. The distance between vertices is my 2a. So vertices sub 1 length to vertices sub 2 is 16, because you're up 8 and down 8. That distance between them is 16. That is my 2a, and a is just 8. From the center to a vertice is the value of a. And so since it's longer up and down, a squared, which is 64, goes under the y squared. And then they give you eccentricity, and E is C over A. 1 over 2 is C over A, and I know A is 8. And this is what I'm saying is when you see eccentricity, don't assume the numerator is C and the denominator is A. It's a ratio. And C has to be 4 for it to be a 1/2, right? Solve it, cross multiply. C is 4. And then you need to use that C squared is A squared minus B squared. So that is 16. A squared is 64 because it's longer vertically. So the A squared goes under Y squared. And so your B squared is 64 minus 16. And that is 48. And that is, I mean, we don't need B necessarily. We need B squared. And that's it.